I'm gonna show you a model stepper motor which I made to show and demonstrate the components inside a stepper motor and explain how it works. The first things I need, it was some meters of wires like this. It is 22 turns of very thin wire, as you can see it, and also I used a magnet like this. These oval little magnets, they're almost strong magnets and usable for some industrial usages. You can easily use them as you want. As you may know, the rotor part of a stepper motor is a constant magnet like this, and I'm gonna use this magnet as the rotor of my stepper motor. To do that job, I used some wires like these and two syringes to keep it vertically like this, and as you can see that it stands with itself. And by the way, I can have minimum rigidity and friction at the end points of my shaft of my stepper motor. As you can see there, this is the syringe needle, and also I put some signs over here to show the direction of the magnet and let you see the reaction of the magnet as my rotor inside this video. Okay, to show it perfectly to you as a minimum rigidity and friction in the shafts, we got to put this device vertically upon a very smooth and hard surface. I got a ceramic tile as my surface over here. As you can see that it is a ceramic tile which is perfect for the job, and I'm gonna show you how it works. As you can see that in this video, this rotor turns freely, and you can see the north and south poles signs that I wrote over it. And it is time to show you how it works. We are going to create a magnet, a non-constant magnet around my rotor, because the stepper motor is gonna turn it left or right as we desire and control the magnets and windings. To show the freely turning rotor of this stepper motor, I'm gonna use this magnet and go near to the other magnets. Now you can see that it is turning, right? If I turn this one, it turns too. I'm turning this one to the left and the other one turns to the right, the reverse direction. and it is perfectly turning with minimum friction at the shafts of the stepper motor. This is great because we're gonna use a single winding to turn this as a stepper motor. I have used a flip-flop as the driver of this stepper motor, which provides enough energy to turn the rotor of the stepper motor perfectly, as you could see in the video. And this simple flip-flop actually is a timing circuit for the driving the stepper motor, and I use a orange LED to show the charging time of a huge capacitor and a red LED for the discharging time of this capacitor, which is discharging into this coil through a simple relay. And this simple flip-flop with two simple transistors is as a timer with about 3 seconds for every period of it. This flip-flop is working with 12 volts of DC voltage, which is provided by a switching power supply out of the frame. Now it is time to set up the stepper motor and run it for you and show you how it works. This part is a rotor for my stepper motor, and the coil should be as near as possible to the rotor, and the rotor should be freely able to turn. That seems okay, and I should keep it constantly over here. Is it free to turn? Yes. Okay, it is ready, and I'm gonna show you how this flip-flop can turn the rotor of a stepper motor over here. As I said before, during the orange light, this huge capacitor, which has a capacity like 6,800 microfarad, charged up to 12 volts, and during the red light, the same charge discharged to the coil of the stepper motor through that black relay. And this simple flip-flop with two simple NPN transistors, as you can see there over here, and it controls the timing. And as you can see that the rotor, the constant magnet, as the rotor of this stepper motor turns clockwise. It is turning clockwise. To reverse it, you got to replace this wire with that wire, nothing more. Also, there is another NPN transistor which controls this black relay and lets us to prevent interference. This part of circuit, which is the power part, with that part which is a timing part for this simple stepper motor. Okay, I'm gonna keep this coil constantly because it moves and wastes a part of energy, but if you keep it constantly there near to the magnet, it can turn the magnet pretty well. You can see it here. Do you see that? It turns a lot. And this rotor turning produces the torque of a stepper motor, and we can get that energy from the shaft of a stepper motor. Of course, this stepper motor has only one winding because I tried to make it very simple, to make it very compact, to show only for a video purpose. But you should know that stepper motors, real stepper motors, have more than 2 or 4 or 8 windings inside. And as you increase the distance between magnet and the core of the coil, the whole torque of the stepper motor reduces. You can see that over here. I just increased, and you can see it will less turn again. Of course, it has some effects, but since the distance between the magnet and the coil has been increased over here, it turns just a little bit by red light. Again. It couldn't even turn. What about this location? It turned too. Anyway. I should suggest that the timing in this circuit is 2.2282. It means the orange LED stays on 2.2282, and the time constant of this circuit is 0.6392, and also I should suggest that this huge capacitor will charge at the maximum voltage within 3.196. And most interesting point about this circuit is this: the whole amount of electrons charged inside this circuit, inside this capacitor, is 0.09588 coulomb.